All right, my name is Wen, and this is a project that I worked on this semester under the mentorship of Edmund and Shilpa and under the guidance of Professor Satya. And this project is on tracking productivity in an edge-based image discovery tool called Eureka that was developed in Satya Lab a year ago. Effectively, what Eureka does is that it helps users build large data sets effectively. You can imagine that there's a huge data set of unlabeled data, let's say all the Yahoo images, and you want to find specific instances of whale pictures, let's say. What machines can do is they can filter out very obvious negative examples so that the user doesn't have to go through these obvious negative examples. So in this case, you can see that we have filters on cloudlets, and these filters can filter out, let's say, images of humans or images of tigers, and these images, and only images of like sea animals will pass through. So now you have a very focused subset of data that the experts can now focus on labeling. Part of this process, we can measure the productivity of a user by looking at this equation here. So the productivity can be defined by the amount of actual whales, let's say, you labeled over the amount of elapsed time. And tracking productivity is very important because in the initial iteration of Eureka, it was actually very hard to track your productivity during this process of using Eureka. Namely, tracking productivity allows the expert to be aware of two things in particular. One thing is a computational bottleneck. So yes, these models can filter out very obvious examples, but you're kind of bottlenecked by the speed at which these models can filter out, right? Because the user will not be able to label anything if it doesn't get any images to begin with. That's why oftentimes, let's say if you only had one cloudlet, the user could be just bored the whole time waiting for more images to come in to label. This is where edge computing comes in, and you can increase the number of cloudlets, and you do all of this in parallel, and this highly parallelizable task, so then the user can be fully occupied and maximize the user's productivity. And detecting when you are computationally bottlenecked requires knowing your productivity, and that's what we sought out to tackle this semester. The second thing is that you can track whether your model has been improving or whether it has been overfitting, and it's also you can also see that from tracking productivity, right? So let's say you feel like there's a lot of images coming in, but suddenly there's not so many whales anymore. Maybe your model has degraded in the last iteration, and maybe you want to restart the last iteration with a better model and see if that improves your productivity instead of decreasing your productivity. So in particular, our contributions can be summarized as follows. We built a history window which tracks the productivity of the users in a live fashion, and it reports this through a web browser. And it allows three logging features. One is that it visualizes session statistics, so including productivity, accuracy, precision, at very fine granularity to track the progress between sessions so that people can see, the users can see that these metrics are actually improving in a positive way. Second thing is that it enables restart from a previous checkpoint. So we store all the metadata that identifies a single session, and this metadata can be downloaded by the user from this history window, and the user can now load it into the Eureka app or the Eureka UI and restart the previous session if, let's say, the model degraded. And finally, it allows a full replay of the search session. And this is particularly useful if you imagine tasks like detecting tumors in X-ray images, right? Where you require the task to have very high precision. And so maybe you want multiple doctors to look at it at different times instead of just having one doctor label it as positive and have it being like a false positive, right? So because we track all the images, later doctors can come in and they can verify that the label is indeed correct. So let's go to some of the technical details now. Over here, you can see sort of the data flow that's going on in Eureka as well as the history window. So if you just zoom in over here, we have the cloudlets and the hyperfind. This is what Eureka was before the history window. What we've added is we've added logging features to hyperfind, and then we've added a Flask web server, which can read this data and serve all this data to your Chrome browsers. Kind of like if you're familiar with TensorFlow, there's something called a tensor board, which is something that TensorFlow developed for you to visualize your training statistics during training time. This is exactly what we've done for Eureka. Now this allows the user to visualize all the statistics during the labeling session. And the specific details are as follows over here. Because we track so many things, we have to track them at different times, right? So one thing is that we want to track image level granularity. That means every time an image arrives, we want to track its thumbnail so that we can replay it later, and we want to track its metadata, also for the replay, right? As well as tracking the ID, all of that. We also want to track the statistics such as accuracy, precision, productivity at each image arrival. And this enables us to make the fine-grained plots that you see over here. We also track session-level metadata, such as the predicates used in the session. The predicates is another name for filters. And we can also track the type of the session as well as the start and end time of the session. And all of this information is useful for the user if the user wants to restart a session, let's say. In particular, I want to show how you can specify the session name. Right? So for example, you can specify her over here, and if you use a session name of demo, let's say, then whatever session you start is going to be logged as demo on the web server. So that's how you actually initialize the web server. Yeah. All right, so we have the Eureka window here, and this is the history window. And effectively, the history window is started at runtime. Like whenever you start the Eureka session, the history window automatically gets started in the backend, the Flask web server. And by doing an SSH forwarding, we can now open the web server, the web data on my computer's browser. And so we can see that, let's see, during the Lotus session, so it automatically plots a summary of the session. So items processed over the session, the number of items shown, new hits, and pass rate. And then the plot should see that this is the number of items shown, this is the number of new hits, so the number of positive images that the user has labeled. And you can view the productivity. So this is the case where we indeed had multiple edge servers, and these cloudlets could keep the user fully engaged throughout this whole process. And you can see the productivity increasing. Here's also a replay window where you can see all the images, right, that were played in the session in the order that they were presented. So if I wanted to verify that some of the labeling marks, so for example, this one had a positive mark for being a lotus, I can actually come here and verify that it indeed is a lotus and this was a correct label. What we can also do is we can download the predicates that were used for that session specifically. And if we wanted to repeat that session, it's as easy as importing this predicate into Eureka by using the import button over here.